Hi, today we're going to talk about constructing and interpreting graphical displays of distributions of univariate data. One of the ways to display univariate data is through a histogram, which you may be familiar with. This one is of tree heights, and some of you may remember it looks very similar to a bar graph. The difference is that there's no space between the bars. And this first bar, for example, represents all the trees that are between 100 and 150 centimeters. So it's not just 100 or not just 150, it's everything in between. And so this would mean that there was about 4 trees, because that would be from your y-axis, that knowledge of 4, that fall between a height of 100 centimeters and 150 centimeters. And so each one can be interpreted as a range between the first number and the second number. Next we have a dot plot, and it's exactly what it sounds like. It's a plot of dots. This one is a random just example to show you what it looks like, and it has the numbers 0 through 9 on the horizontal axis. Each one of the dots above those numbers represents how many of the data points fall into that category. So if this were a questionnaire that had asked people what their favorite number was, for example, there would be 3 people who said their favorite number was 1, or there would be 4 people who said their favorite number was 6. That would be how you would interpret a dot plot. And they're very easy to make, and they're an easy way to see kind of where people like things if you're trying to poll a bunch of people. Our next graphical display is a box plot, and a box plot is a little bit more complicated than the others. It can give you a lot of information. The bare minimums of the information it can give you are the spread of your data. For example, the smallest number is where you would find your minimum point, and the largest number is where you would find your maximum point. If you lined your data up in a line, the median is the middle number, and so that is represented here on a box plot. The Q1 and Q3 are the first quartile and third quartile, meaning they're the center of the first half of the data and the center of the second half of the data. And I will show you in a future video how to create a box plot. Our next display is a cumulative frequency chart, meaning that it adds up, because cumulative meaning adds up. And so if we're looking at the ages of 10 to 17, this point at 12 and about 40 would mean that there's 40 total, age 10, 11, and 12. So it's adding up not only the people who are 12 years old, but it's also the 10 and the 11. So this increases a little bit each year that is represented. Our next display is a stem plot. Some of you may know it as a stem and leaf plot. And here's an example. You need a key for it a lot of times. This one reads that 1/0 equals 10. So in other words, if I had 1/0, it would be 10. Up here, if I look at the 1/2, that would be 12. The 4 is beside of that. That doesn't mean 124. That actually means that in the 10's place you have the 1, and in the 1's place you have the 4, so that's 14. There's nothing beside of the 2, which means that there are no data points in the 20's. However, this line of 3's would mean that you had a 33, a 34, another 34, 2 35's, a 37, and a 38. And so that is how you read a stem plot, and they're fairly easy to make, and they're good for small sets of data. Okay, we will also need some vocabulary words to be able to describe and interpret some of the data graphs. Symmetric is a word that occurs in nature and in other mathematical courses that you may take. It means that it appears to have mirror images across the center, and so a butterfly is typically considered symmetric because if you drew that line down the middle, the left and the right would kind of mirror image each other. Triangle and isosceles triangle is the same way. The left mirrors the right. And so with these data sets, sometimes it will appear that there's a mirror image. And we're going to look at some examples momentarily and decide about that. 2 more words that we'll need are unimodal and bimodal. And unimodal means that the data appears to have one peak. So if we were to draw it, it kind of looks like it has one hill. Bimodal means that the data appears to have 2 peaks. So it may have 2 hills in the data. And again, this is going to be on histograms and stem plots and dot plots where you'll be looking for these hills or unimodal and bimodal descriptions. If the data is not unimodal or bimodal, it can be considered uniform and it's evenly spread. You could almost draw a horizontal line across the thing. There's no clear peak to it. It may not be perfect, as most real-world data is not. But if there's not a clear peak or clear peaks, then we will probably consider it uniform. And again, I'll show you some examples in just a moment. Okay, before we look at those examples, I do want to mention one thing, and that is if a graph is both symmetric and unimodal, it may be called mound-shaped or bell-shaped, and this is a very popular description for data as a bell-shaped curve. So again, it kind of is unimodal and it's probably a little more symmetric than I can draw. But again, that name or that terminology may be something you're familiar with, a bell shape or a mound shape. Okay, this is our first example, and we are going to discuss which of the vocabulary words apply to it. First of all, even though it's not perfectly symmetric, if I drew a line right down through here, it would almost be a mirror image. And as most data sets in the real world aren't perfect, we're going to consider this one good enough to be called symmetric. There's another thing we want to notice, and that is that it does kind of have one heel. And so one heel, we're going to classify that as unimodal. For our next example, we have another histogram, and this time, if you'll notice, it kind of has 2 peaks, a mountain here and a mountain here, and so that would be bimodal. You also may notice that if you drew a line right down through here or somewhere close to there, it would be fairly symmetric. It looks like it's a mirror image, so I would also classify that as symmetric. This example is what I would consider to be uniform because it's about straight across. It's not a clear peak, and so we are going to call that uniform. And it's not perfect again, but it's not really a clearly peaked data set. This last data set is a histogram, and it has a little bit of a special property here. First of all, it does have the one heel, so it is unimodal. But it also has the property of being skewed. It has an outlier out here, and so we're going to talk about what it means to be skewed. Okay, skewed graphs are unimodal graphs, so they have one heel, and they tend to slant to one side. Most of the data is clustered on that one side, and it's what we call tailing off on the other side. So we'll look at some of those. Okay, left skewed data, or data that's said to be a negative skew, is clustered on the right and it tails to the left. So if you look at each of these examples, they all seem to have a cluster on the right and a little bit on the left, kind of tailing off to the left. So that's a left skew. Right skewed data is the opposite. It's also called a positive skew, can be called a positive skew. It's clustered on the left side and tails off to the right. So if you look at each of these examples, majority of the data is on the left side, and you have small amounts on the right side, so it is trailing off to the right side. Okay, so now I'm going to give you a chance to create your own graphical interpretation. And for this first one, I have the heights of 30 people in centimeters. They're ranging between 139.5 centimeters to 199.5 centimeters. And this I want you to make a histogram. So I'd like for you to pause and create your histogram, and then you can check it. Okay, so your histogram should look something like this, and yours is probably not perfect, mine's not perfect, but it does represent the data. We have a range between 139.5 to 149.5 at about 6, and so that matches. The next one was about 9, the next one 7, and so each one of those heights again represents the total number of people falling in that range. So hopefully yours looks something like mine. It's definitely unimodal, and it appears to be a little bit skewed to the right. Okay, for this last example, I would like you to take these test scores and create a stem plot. So you'll do the tens numbers on the left, put a line, and then your ones numbers on the right. And if you'll hit pause, you can check your answer in just a moment. Okay, this is what that stem plot looks like. It's definitely unimodal and skewed to the left. So hopefully yours came out similar to mine. I look forward to our next lesson. I will teach you to create some other graphical interpretations.